So now that you have seen that the angle that the blood drop hits does have an effect on what the drop looks like, the next thing that we need to learn how to do is calculate the angle of impact. At what angle did the drop hit? Because once we have this information, we can use it to determine what we call the point of origin, where all the blood's coming from and how high it came from. So if this is the ground right here, the path of your blood drop comes in, hits the ground. This right here is the angle that we're looking for. That's called the angle of impact. And the way that we find this is that we do a little bit of math. There's a little bit of trig involved because this makes a triangle. So you can use the widths and the lengths of the drop and the sine inverse to determine the angle of impact of the drop. I should say angle of impact. Okay, so it's the sine inverse. So here's how we do it. If this was our drop, so I took this right here and this is what it actually looks like. If this was my drop, the first thing I do is measure the width of the drop. So I measure from one side to the other. I recommend that you always measure in millimeters. So you put your ruler down, okay? And remember there's 10 millimeters in every 1 centimeter. So if I'm looking here at my ruler and I'm measuring, I'm gonna say that this is 39, the width of my drop is 39 millimeters. Okay, 39 millimeters. Then I'm gonna measure the length of the drop, but when I measure the length of the drop, I do not include the tail. So when I measure the length, I'm gonna start from here and I'm gonna go to here and I'm gonna measure the length of my drop. I'm gonna measure it in millimeters again. And so as I'm measuring, I'm getting, it looks like 98 millimeters for my length. And obviously these are really big numbers because I drew this and the drop's way bigger than what it would actually be, but that's the idea. Then I use this equation down here. So the sine inverse width divided by length. So it would look like this when I put it in. The sine inverse, my width was 39 millimeters divided by my length, which is 98 millimeters. Here's how you properly plug it into a calculator. Okay, so here's my calculator. Okay, I'm gonna turn it on and I'm gonna do 39, which is my width, divided by 98, which is my length. I'm gonna hit enter and then I'm going to hit second sine because I want the sine inverse. So based on my calculation, and I always round up to a whole number, based on my calculation, it's 23.45 degrees. So I'm going to round that up to 24 degrees because it's going to round up 0.5. This particular drop hit at a 24 degree angle. So at 24 degree angle, this drop, based on what it looks like, and its widths and its lengths, hit the ground at that angle. And then we'll explain how we use the angles of impact for point of origin. So, now that we've talked about that, let's take a look at your angles of impact for your lab. Okay, and let's see how close that you got. So I'm gonna do kind of the measuring, and then we'll let you guys do the other part. So for the 15 degree angle that you guys had here, you know it got dropped at 15, but let's see how close we actually were, keeping in mind that there were probably some errors that were involved in holding the board and so on and so forth. So the width of my drop is here. The length of my drop is here. Okay, so I'm going to measure the width. And I'm measuring my width for this one at 9 millimeters. I'm going to measure the length. And my length is 44 millimeters. Okay, so plug that into your calculator. Remember, you're going to do the sine inverse 9 divided by 44 and see what you come up with. I came up with approximately 12 degrees, which is pretty close. We were aiming for 15 degrees, so barring a little bit of error in how I was holding the clipboard, that's pretty close. So now let's try this one. I calculated it out to 14 degrees, which is pretty close. So those are pretty close to 15 degrees, barring a little bit of error. Okay. So now, let's try your 30 degrees. I'm just going to do one of each of these, and I'll do the measurements for you, and then I'll let you guys do the math part of it and plug it into your lab. So the width is 13 degrees, and the length, keeping in mind I'm not using the tail, is 37 degrees. Or sorry, not degrees. The width is 13 millimeters and the length is 13 millimeters. So for your 45-degree one, the width, it looks like, is 14 millimeters. And your length for this is 30 millimeters. So width is 14 millimeters, length is 30 millimeters. For your 60 degrees, the width is 22 millimeters. And the length, not including any spines, looks like it's about 27 millimeters. Keeping in mind that you're going to get an error in your calculator if your widths are greater than your lengths. If they're the same, it'll be a 90-degree drop, a perfect circle, but if your lengths are bigger than your widths, you've got some type of error somewhere. Okay, and the last one is our 75 degrees. So let's see, we'll do this one for 75 degrees. Your width is 23 millimeters. And your length for this one, let's see, looks like 25 millimeters. So you can do your calculations, and then you can put that into your data sheet. So your data table is going to ask you for a calculated and a measured. The calculated is what you're doing right now. The measured angles of impact were the ones that we did in the lab. So those should be 15, 30, 45, 60, and 75. And then you are going to compare the calculated, and then you'll be able to see what differences there are, and so on and so forth.